So with this problem here, let's go shopping. Let's figure out what we need to do in this problem. We've got a sample of helium, occupies 2.5 liters at a pressure of 500 millimeters of mercury. What would the volume be if the same sample occupy at 1.4 atmospheres if there's no change in temperature? So the fact that there's no change in temperature just tells us that the only things that are involved in this are pressure and volume. So my initial pressure, we'll call P1, is 500 millimeters of mercury. My V1 is 2.5 liters. My P2 is 1.40 atmospheres, and my V2 is what I'm looking for. The issue is I can't plug this into the formula for Boyle's law right away because my pressures are not the same. They have to be in the same units. So we can either change atmospheres to millimeters of mercury or millimeters of mercury to atmosphere. I just happen to choose atmospheres to change it to millimeters of mercury. So 1 atmosphere, ATM, is 760 millimeters of mercury. And if you do the math, you should end up with 1,064 millimeters of mercury. And now we're going to ready to plug that into the equation. P1 V1 is equal to P2 V2. We're going to solve for V2 by dividing both sides by T2. I'm sorry, by P2. And now we end up with V2 is equal to P1 V1 over P2. And now we're ready to plug in our numbers. Our P1 is 500 millimeters of mercury. My V2 is 2.5 liters. And my V2, or P2, is 1064 millimeters of mercury. Units of millimeters of mercury are going to cancel on out. And now we just divide, and we should end up with a new volume of 1.17 liters. We should always make a mental note that makes sense. Our pressure went up, more than doubled, and we know pressure and volume are inversely related, so my volume should at least more than halved, and 1.17 is less than half of 2.5. So that's how we do 30.